All right, so 3.4 is called measures of position and outliers. So the first thing we're going to talk about, and we're just going to talk about the calculation of your z-scores and not necessarily the application. We'll get into the application later. But your z-score is just the distance a data value is from the mean in terms of standard deviations. Yeah, the distance a data value is from the mean in terms of standard deviations. So remember last class we did our empirical rule in which we were talking about being one standard deviation away, two standard deviations away, three standard deviations away. Well, your z-scores let you be more precise. So you can be like 1.23 standard deviations away or 2.57 standard deviations away. So the general way we would calculate our z-scores is that we would take our data value, subtract the mean, and divide by the standard deviation. And that's what I have here in the red. Data value minus the mean, divide by the standard deviation. And remember I said that the population of sample has different symbols. And so that's what the green and the purple represent for us. But it's still the same thing. You're doing your data value minus the mean divided by the standard deviation. So no matter whether you're doing a population or sample, you're still doing the same process that's held in the red. Your data value minus the mean divided by the standard deviation. All right, can I scroll up? All right. So before we get to the example, notice it says the z-score is unitless. And in general, it has the mean of 0 and the standard deviation of 1. So when you go to look at the chart, that basically says that, let me do this in red. When you go to the middle, 0 is going to be in the middle, and that would be the mean. Because we're going to have a z-score chart. And what's going to be in the middle is your mean, which is going to be 0. And then everything else will go from there. So to the right of 0 will be all positive values. To the left of 0 will be all negative values, just like you would in a regular number line. And don't forget, if I scroll up too fast, let me know because I can't see anybody. So, first example, determine whether the Angels or the Rockies, and I must have been tired. I was writing this a little lazy. But anyway, determine whether the Angels or Rockies had a relatively better run producing season. The Angels scored 773 runs and play in the American League, where the mean was 677.4 and standard deviation was 51.7. The Rockies scored 755 runs and play in the National League, where the mean was 640, standard deviation was 55.9. So I'll give you guys a chance to write that down. So you notice they mentioned the American League versus the National League. So if you don't know about baseball, the American League has different rules than the National League. Minor different rules, but their scoring, it may impact the scoring as far as the rules are concerned. So that's why they emphasize one was in the American League, one was in the National League. So that means that we're going to be comparing the National League to their respective, let's say the Angels in the American League, so they would be compared to the American League stats. Rockies in the National League, they will be compared to the National League stats. All right. I scroll up some. Like I said, let me know if I go up too fast. All right, so right here, I just wrote down the given information. So your Angels, scored 773 runs. That's going to be the data value that we're doing our comparison and calculation for. In the American League, you had 677.4 as the mean, 51.7 as the standard deviation. For the Rockies, they scored 755 runs. 640 was the mean in National League, and then 55.9 was the standard deviation. So that's the given information. Haven't done any calculation yet. Just wrote down the given information. All right. So to find your z-score, and for the Angels, we'll do 773 minus 677.4 divided by 51.7, and that'll give us 1.85 as our z-score. For the Rockies, we'll do 755 minus 640.4 divided by 55.9, and that gives us 2.06 as a z-score. And you always round your z-scores to 2 decimal places. That will matter when we start doing our z-score chart. So I'll give you a chance to write that, and then we'll talk about what that means. All right, so we talked. What that means is that the Angels scored 1.85 standard deviations above the mean. Notice I mentioned above the mean because it's positive. If that 1.85 was negative, then I would have said the Angels scored 1.85 standard deviations below the mean. So you're talking about below and above the average. Remember, the mean means average for us. So Angels scored 1.85 standard deviations above the average. The Rockies scored 2.06 standard deviations above the average. And don't forget, the Angels scored 773 runs. The Rockies scored 755 runs. So the Rockies scored less. But above the average in the National League, they scored more as far as standard deviations are concerned. So that means the Rockies had a better run producing year or season than the Angels. All right. Questions on that before we go to the next thing? All right. Next thing here is the percentiles. The kth percentile of a set of data is a value such that k% of the observations are less than or equal to the value. So represent the percentage that is less than or equal to the value that you're discussing. Kth percentile is denoted by P sub k. You have a small number, and you'll see the number in a second when we actually do an example. All right, so example that refers to the percentile. Jennifer just received the results of her SAT exam. Her SAT math score of 600 is in the 74th percentile. What does this mean?
Could this go back up a little bit? Yeah, right there is fine. Thank you.
All right, let me know when I can scroll back down.
Okay, that's fine.
That's good.
Yep.
All right. Are we done with black altogether? Anybody need black?
I'm good.
You say you do?
No, I said I was good.
Oh, okay. All right. So we at the green. Like I said, that's what I'll just rereading. Jennifer just received the results of her SAT exam. Her SAT math score of 600 is in the 74th percentile. What does this mean?
It means she did better than 74%.
Mm-hmm. 74% of the people who took the exam scored 600 or less, and then 26% scored better than her. And so you find that 26% by subtracting it from 100. That's what I did right there, just emphasizing this 100 minus the 74. Okay. All right. Am I good? Am I good?
Yes.
Mhm. So quartiles. Remember, our medians divided our data into halves. Quartiles will divide our data into fourths. So you see what we have there. We have our minimum. If we had a number line that represented our data set, notice we had a minimum and maximum on the ends, and then quartile 1, quartile 2, and quartile 3 split up the data into 25%. All right. So finding your quartiles. First thing you want to do is list your data values from least to greatest. Second, notice we find quartile 2 first. And that's just going to be the median of the whole data set. So that's going to split your data into half. In other words, 50% on both sides. Then we'll find quartile 1. That's going to be the median of the first half of data. And then quartile 3 would be the median of the second half of data. And so all we're really doing is finding three medians. Median of the first of the whole data set, then the median of the first half of data, then the median of the second half of data. First thing you got to remember to do though is not to forget to list your data values from least to greatest. That has to be done first. All right. Scroll. And we're going to apply finding the inner quarter, apply finding those and everything in a second. I'm going to show you a bunch of processes, not a bunch, a few more processes. And then from there, we're going to apply them all. Let me see. Yep. So about 2 more things, and then we'll go ahead and apply it to an example. So your inner quarter range, IQR, is just the range of the middle 50% of the data set. And you find your IQR by subtracting Q1 from Q3. Next up, no, I'm scrolling up. I think this is the last one before we do. Yep. Okay. So now we're looking at checking for outliers. Remember, those are extreme values in comparison to your data set, whether it's very, very large or very, very small. We will have what we can call the upper fence and the lower fence. We'll take quartile 3 and add 1.5 times the IQR to establish the upper fence. And then to establish your lower fence, you take Q1 and subtract 1.5 times the IQR. So the reason why these fences are necessary, because you can look at something and just say it's an outlier, but that doesn't mean it's actually an outlier just because it's large as far as your view is concerned. But these give us our boundaries. So give me 1 second while you guys copy that. Let me make sure this is not an emergency. Sorry about that. Of course, it wasn't an emergency. That's a good thing, though. All right, so if a data value is greater than the upper fence, then it is an outlier. And then if a data value is less than the lower fence, it's considered an outlier. So that's what these fences are for us. They're boundaries to establish what an outlier is or isn't. It gives us an actual number to look at and say, okay, if it's greater than this number, it's an outlier, or if it's less than this number, it's an outlier. So that's why we need to establish those fences. All right. And we scroll down. Everybody good, good, good. So let's apply these processes, and we'll do them in steps. Okay, just trying to make sure I didn't leave anything. So let's erase this stuff. So we can walk through it. All right, so the first step is that you're going to list your data values from least to greatest. So they will give you a data set, and this is our data set. Now I wrote them. We have 18 data values right here, and I wrote them, with 9 as my first half, 9 as my second half, just to help us with the breaking up of our data values. And I listed them from least to greatest. And what I didn't want to do was write a whole bunch of numbers multiple times. So I just went ahead and wrote them from least to greatest. This is our data set. We have 180, 189, 370, 618, 735, 802, 1185, 1414, 1657, 1953, right at 3 better. 1953, 2332, 2336, 3461, 46, 66, 68, excuse me, like that a little better. 46, 68, we got 6751, 9908, 10,034, then 21,147. So these are 18 data values. I listed them, like I said, in halves. So we can, so it'd be easier for us to break down what our quartiles are. All right. So once again, your first step is to list your data values from least to greatest. All right, so step 2 is to find quartile 1. What we're about to do is apply, everything we talked about to the quartiles, from the quartiles to this data set. And we're going to end up finding our outliers and all the good stuff like that. So we want to find quartile 2, and that's the median of the whole data set. Now, if we have 18 data values, remember, in order to find the median, since we have an even number of data values, we'll take the 2 middle values, add them together and divide by 2. So that's what I did here. 1657 plus 1953, divide that by 2, and that gives 1805. All right, questions on quartile 2, what we did there, why we did it. All right, so now step 3 is to find quartile 1. Now notice we have 9 data values in our first half of data, 9 data values in our second half of data. That 1657 is not quartile 2, so that's still a part of the first half of data. Same thing with the 1953. So a lot of times what people do is they make the mistake is say, okay, because I used it to find quartile 2, then I don't use it in my data set. No, 1657 is a part of the first half of data. 1953 is a part of the second half of data. Quartile 2 is 1805. Okay. So we have 9 data values in the first half, 9 data values in the second half. So since that's an odd number, that means we actually have a middle value, which is 735. All right. Then for quartile 3, same thing. That's going to be 4668. We have 9 data values. Remember, when it's odd and you want to find the median, you can just pick the middle value. But if it was even, you have to take the 2 middle values, add them together, divide by 2. And that's what happened with our second step when we found a quartile 2. All right, questions before we go to the next step? All right, step 5 is to find your interquartile range. So you would take Q3 minus Q1, and that's 3933. Step 6, determine your fences. So we have the upper fence and lower fence. So my upper fence, to calculate the upper fence, you do Q3 plus 1.5 times the IQR. 1.5 is just a part of your formulation. That's where, that's where it came from. There's nothing for you to find. 1.5 is a part of the process. So that's Q3, which is 4668, plus 1.5 times 3933. That was our IQR. That gives us 5899.5. And then that gives us this number right here, 10,567.5. So if any number is greater than that number, then it is an outlier. Then we do a similar process for the lower fence. Q1 minus 1.5 the IQR, so it's 735 minus 1.5 times 3933. Ultimately, we'll have negative 5164.5. So if anything is less than that 5164.5, that negative 5164.5, then it would be an outlier. Any questions? All right, can I scroll up? So we will use this to determine if there are any outliers. So you ask yourself, are there any outliers? The answer is yes, because the 21,147 is greater than the upper fence. It's greater than the upper fence. All right, so any questions before we go to 3.5? So 3.5 is going to use all of the same stuff, so we won't be doing anything new. Just emphasize one or two more things. Any questions? All right. So 3.5, the 5-number summary and box plots. All right. So your 5-number summary is your minimum, Q1, Q2, Q3, and your maximum. So like I mentioned, we've pretty much already talked about that. They just didn't call it the 5-number summary. So we saw the minimum and maximum, smallest and largest values, and then we found Q1, Q2, and Q3 through our process. Scroll up. Very good. The other thing in this section that they talk about that we haven't already, box plots. It's a graphical tool used to compare groups of data. It consists of a box with lines that are extended to the minimum and maximum values that are not outliers. So different books call for different things. This one, our book, we're going to do a modified box plot wherein we're not going to extend to what we have considered outliers. And you'll see what I mean in a second. These lines are called whiskers. And the outliers can be represented or are represented by an asterisk. So remember, our lines are not going to extend to the outliers, but you will have asterisks there that represent the outliers in your box plot. All right. So here's a generic example of how a box plot would look. You have the minimum, maximum. Remember, there are minimum and maximums that are not outliers. Q1, Q2, and Q3 would be points that are in your box that will make up your box. And then notice I have outliers over there to the right, which would be considered asterisks, or would be represented by asterisks. All right, questions before we use this information to examine a data set? Scrolling up. Everybody good? All right, okay. So give the 5-number summary and sketch the box plot. So it says the data set is not, I was just mentioning this because, you know, I'm going to just write it in order. But your data set is not always written from least to greatest. Make sure this is the case before you move forward. I just want to keep driving this point home because a lot of people will have made that mistake in the past. They forget to write it from least to greatest and they do all the other steps correct, but that doesn't matter if you didn't first start off with writing your data set from least to greatest. So once again, I just want to reiterate that point. So we have a new data set here. And let me erase. All right, I don't want to move up too fast. Everybody good? All right. So this is my data set. They didn't give it to you like this, just like before. I wrote the data set in such a way that it would be easy as far as breaking it up. We had 21 data values. So that means we did have a middle value, and that's how I wrote it. Got my first half of data, wrote 30.9 in the middle, and then my second half of data. Like I said before, they will not set up the data set this way. That will be on you to do. So what I normally do is count how many data values I have, and figure out, you know, if I have a middle value or not, how I would break it up and everything like that. So if you look at what we have 19.95, 2325, 2332, 2555, 2583, 2628, 2858, 2872, 3018, 3035. 3095 is in the middle. We got 32, 13, 33, 23, 33, 53, 36, 68, 3705, 3743, 41.42, 42, 47, 49, 17, and then 5463. Just like before, I'll give you a chance to write those down. All right. Can we scroll up? Are we good? All right, let's do that. So our next step is to find Q2. Remember the way I set it up should be easy for us to see Q2. We have 21 data values, so our middle value is Q2, so no calculation needed there. All right, so now we need to find Q1. My green back. And so that means since if we have 21 data values, that means we have 10 data values in our first half of data, 10 data values in the second half of data. So that's even. So we don't have a clear middle value. That means we need to take the two middle values, add them together and divide by 2. So that's what I did here. 2583 plus 2628, add them together, divide by 2, and that gives us 26.06. All right, same thing for the second half of data, finding Q3. We're going to take 3705 and 3743, add them together, divide by 2. That gives us 3724. Everybody okay?
I think so, yeah.
All right, thanks. Thank you for that. Appreciate it.
So far, so good.
And so then we find step 5 is find the IQR. Q3 minus Q1. 37.24 minus 26.06. It gave us 1118. So, you know, when we look at what we're doing here, if you follow the steps, they're not really asking you for hard calculation, just need to know the steps. So if you stick to the steps, we should be good as far as the process is concerned. And we establish our fences by using the IQR. So the lower fence, Q1 minus 1.5 times the IQR, that will give us 9.29 once you've done your calculation. And then upper fence, Q3 plus 1.5 times IQR. That'll give us 54.01. So the reason we need this, just establishing why we need our fences. If a value is less than the lower fence or greater than the upper fence, it is an outlier. Then for that last step, you determine your outliers, see if you have any compared to your fences. And so we see that 54.63 is an outlier because it is greater than the upper fence. All right. So you need to perform all of those steps, all 7 of those steps, in order to be able to do your 5-number summary and your box plot. All right, so before I go to the 5-number summary, is everybody good?
Good.
All right. So here's your 5-number summary. Now, don't forget your 5-number summary doesn't have anything to do with outliers. So your minimum value is 1995, Q1 260206, excuse me, Q2 3095, Q3 37.24. Then your maximum value is 54.63. Now that's your 5-number summary. That has nothing to do with whether something is an outlier or not. Any questions on the 5-number summary? All right, so then your box plot will look like that. Go to 1995 as our minimum. Remember, that wasn't an outlier. Q1, Q2, Q3, so it's 2606, 3095, 37.4. And then remember how we were doing the outliers? They told us to extend our whiskers to the maximum minimum value that is not an outlier. So that 49.17 was the next highest on the list. And we found out that 54.63 was an outlier. So we would just represent that as an asterisk. All right. Questions. All right. So that's it for 3, 4, and 3, 5. That's all they're asking of you out of those 2 sections. Questions or concerns, comments? Everybody good, everybody straight. And some questions may not come up until next class. So is everybody done writing before I go to another screen? Everybody good, everybody good. All right, so let's do this. See if my math lab is still up for me. All right, so your first assignment, great. So a lot of times I don't do quizzes at all. A lot of times what I'll do is I will give an assignment that is would be similar, I guess you would say, to a quiz. If they give you a quiz, they will give you 5 problems. If you get the right one, if you get well, the thing about that, if you miss one, that's 20 points. It'll put you at an 80. You miss another one, it'll put you at a 60. So that's why I don't like doing quizzes necessarily. But I do want to make sure that you assess where you are to make sure you're good going forward. So this is your first assignment, just 5 problems. They're odd, so the answers are in the back. So I wasn't, creating anything to be crazy or to make life miserable for you. Matter of fact, these are 4 problems. So do these 4 problems and see where you are. Make sure you're good. And let's see, today is Thursday. So by next Thursday, shoot me that email with these 4 problems done. You can take a picture of it. If you did it in writing, I guess that would be the easiest way to do it, is to write it out. Then take a picture of it, send it to me through email, just to show that you did it. Like I said, the answer shouldn't be wrong because you can check your answers in the back of the book. But the reason why you would do something like this is to make sure you know how to get the answer that they have in the back of the book. And just re-emphasizing the stuff that should be emphasized in my math lab as well. So questions on assignment 1, question on what I'm asking of you. And so between, if you have any questions on any of them, make sure you ask them so you can make sure you're clear moving forward. I will open up the floor for questions first on next class. So during this weekend, you might want to get in there, see if any questions are being generated, because that's it for chapter 3. So we're done with chapter 3. So make sure you take a look at this stuff, see if you have any issues. Before we do anything on next class, I will open up the floor for questions. And then if we take the whole class, answer questions, that's fine with me. But it's up to you guys, see if you have any questions moving forward. Any questions, concerns, or comments?
Thank you so much.
Not a problem. Thank you guys for showing up. Thank you guys for coming through. If you guys are good, I'm good. I will see you on next class. Have a great weekend and be safe.
Thank you so much.
See you later.
Thank you very much. Take it easy.
All right, take care, guys.
All right, guys, enjoy your weekend.